Alright, hello everyone. This is the video for Integumentary System Notes, Part 1. Part 2 will follow shortly thereafter. So this part basically talks a lot about the structures of the integumentary system. Let's first get to a few thought questions. So first we have name any two structures of the integumentary system. So this is what we talked about weeks ago. Should remember a few of them. And then try to think of any two functions of the integumentary system. So pause the video here and write a couple things down. Okay, so hopefully you put some answers down to those two thought questions. I'll take a look at those when you hand in your homework. We'll go over the different structures and the functions of them in just a few slides. First thing I want to put up, though, was a picture of this guy. He is from the Body Show. Some of you may have seen this. It's kind of been in and out of the Massachusetts area. I think it's down in Rhode Island right now. It's been in Connecticut at the casinos in the past, Museum of Science in the past. I haven't actually seen this one. I saw something similar to it. This is pretty cool, though. Somebody removed all the skin off of one of these donated bodies, and these bodies are real human bodies, and they are preserved with plastination. Basically, a plastic compound is either injected into the body or placed over the tissues and preserves it, and pretty much preserves it exactly as it was in the body. I mean, there's obviously some different colorations to it, but you really get to see. And the average person has about 8 pounds of skin. So this varies huge between somebody who's tall or short, or if they're overweight or underweight, etc. So that's the average. Well, it's the biggest organ in the body. And yes, it is an organ because it's a collection of tissues that perform a, collective function. All right, so to the meat of the presentation. So structures you might have mentioned, and hopefully you mentioned before, were the skin. We also have the sweat and oil glands, the sensory receptors that deal with the skin, which is basically temperature and touch are the big ones. You might have said hair and nails. So those are the big structures or components in the integumentary system. So here we have 3 major groups of tissues. And if you remember, back in the tissue chapter, this was a stratified squamous epithelial tissue. So stratified meaning many layers, squamous meaning flat, and it's not flat throughout the entire, all the layers of the skin. It's more toward the outer layer, but for the most part, most of it is squamous. And it's the type of epithelial tissue because it comes in contact with the outside world. So we have an epidermis, a dermis, and a subcutaneous layer. And interestingly, within the epidermis, there is a thick skin and a thin skin. Thick skin has 5 layers within the epidermis. So there's a lot of layers going on here. So you got the 3 layers here, epidermis, dermis, subcutaneous layer, and then you have 4 to 5 layers in the epidermis. The dermis has a couple of layers. There's a lot of things going on that we have to remember. So anyways, the epidermis, the thicker skin has 5 layers, and the thinner skin has 4 layers. The thick skin is found only on the palms of the hands and the soles of the feet. The thin is basically found everywhere else. All right, this doesn't really make sense here. Feet, soles, and hands. All right, we'll get that part out of there. Anyways, so it kind of makes sense at the bottom of your feet and your hands, which are coming in contact with so many different things in the environment, and there's weight placed on at least your feet mostly, that they may be a little bit thicker. And they are, especially the bottom of your feet. It's about the thickness of a paper towel. Whereas your skin on most other parts of the body has thickness of about a piece of paper. So it's pretty thin in those areas, but thicker in others. And it makes sense, because you need more protection on the bottom of your feet and also on your hands. Overall functions, we got protection. This was your thought question before, so you probably put something along these lines. Like impact protection, chemical protection, protection against infection and dehydration. It's all huge functions. I mean, burn victims really have, if they are burned on a large percent of their body, they have big problems with dehydration. So at the hospital, they'll give them, an IV with that salt water drip. Temperature maintenance, we talked about that when we talked about homeostasis. You have the dilation and constriction of blood vessels near the surface of the skin, help to regulate the heat inside the blood. And we also have varying levels of fat insulation. And fat cells is basically lipid cells. And they are called adipose cells because they make up adipose tissue. The third one is synthesis and storage of nutrients, largely fat and vitamin D. And the synthesis of vitamin D requires sunlight, which is kind of interesting. It's the only vitamin that is made in the body, in the skin, in this fashion. And then, like I said before, sensory perception. Touch, pressure, pain, and temperature are the big ones. This is how we interact, one of the many ways we interact with the outside world. A lot of information coming through our skin at all times, and we'll talk more about that later on, mostly in the next set of notes. But here we're going to focus on, the layers of the skin and the different layers of the epidermis, dermis, and subcutaneous layers. So, we're first going to talk about the epidermis. This is a tough outer covering, and it has multiple strata. So the word strata and stratum mean layers. It doesn't have its own blood supply. Alright, so if you remember we talked about connective tissue before, that should be a hint that these cells potentially are not going to get the nutrients they need, so they potentially could die or have some trouble healing. So we'll talk more about that in just a bit. And the epidermis is made up of really one particular type of cell, and that's called keratinocytes. These cells create a tough, protective, fibrous protein called keratin. And this is similar to the protein collagen we talked about before that makes up your ligaments and tendons and a portion of your bones. Keratin makes up your outer skin layers, and keratin makes up your, well, we'll talk more about that in a little later. First layer we have is a stratum basale, and your book likes to use the other word for it is a stratum germinativum. Alright, so this means basically germination layer. This is the deepest layer, so the deepest out of the 4 or the 5, depending on which thick or thin skin you're talking about. It's the only layer that receives nutrients from the dermal blood vessels. So this is the only layer that is reproducing very, very quickly. As you get further away from this layer, the cells get away from those blood vessels, and they can't do what they need to do. But by the time these skin cells get to that place away from the blood vessel, they've already done what they need to do, so to speak. So they won't be living anymore. They'll be dying as they get away. More on that later. So the stratum basale makes millions of new cells every day, and the numbers are huge. It really should be billions there, if we're talking days, because the amount of cells that are being created is huge, because it's going on all around your body, all the time. These cells are pushed toward the surface. So stratum basale, it can be 30 to 50 cells down. So you're going to have a layer of cells that are being made in this layer, and they're pushing the cells toward the surface, which implies that some of these cells on the surface are going to be going away. We'll talk more about that later. First, since we're on the topic of keratin, here's a couple thought questions. Keratin is a skin protein in the epidermis. It's durable, and it's also water resistant, which is pretty important if you think about it. If it wasn't water resistant, if you went inside of a pool, your tissues would probably start to dissolve. So keratin's a pretty good thing to have if we were going to go in water at all. Another protein like we talked about before is collagen fibers. So they're also in the dermis and subcutaneous layers. They are not in the epidermis, though, those collagen fibers. It's just keratin. So keratin and collagen are sometimes and are often commonly seen in TV commercials. At least you hear about them. What kinds of products are they selling? And the fourth one, can you name something on your body or another animal's body that contains keratin or collagen? Alright, so stop the video here and see if you can put down a couple things for those. Okay, so hopefully you put a couple thought questions down. What kinds of products are they selling? They're usually selling that has to do with something that has to do with hair products. Is usually what they're talking about. They're talking about keratin particularly. The products are usually they'll deposit some sort of fat into your keratin of your hair cells, and the fat will stick to the keratin cells, and it'll make them glossy or shiny or something like that. Alright, so that's usually what's going on with those hair products. If we're talking about collagen, it's usually some sort of skin creams to reduce wrinkles, because when collagen fibers become damaged from UV light or some other environmental cause, or simply just aging, those collagen fibers can become damaged, and basically damaged collagen fibers will form wrinkles. So, can you name something else in your body? Another animal's body contains keratin, collagen. Well, I mentioned tendons and ligaments before for collagen. We're also found in bone, but for keratin, they're found in hair and nails on us, but they're also found in hooves. So these are basically made out of the same material as your nails. And if you think about it, this is like their hands and feet. So this is like their toenails and fingernails in a way. Just evolution has modified them. So they're made out of that. Spiderwebs are also made out of keratin. Feathers are made out of keratin. Strangely enough, feathers are modified hair follicles. Or basically, I shouldn't say modified hair follicles, but they're made out of similar precursor cells as our hair follicles, which is weird. But it kind of makes sense if they're made out of the same stuff. It doesn't take too many changes in the genetic code to make a hair follicle look like a feather. All right? Or make a feather turn into a hair follicle. So it seems like they're very different, and they are, but it doesn't take too many changes in genes. Genes have to be obviously in the right spots at the right times. But when you see that they're made out of the same thing, you can see that evolution is just taking some of the genes we already have and just using the same chemical formulas, but making something different or a different structure. The baleen of baleen whales, which they use this looks like some sort of humpback whale. They eat small little crustacean krill, and they'll grab a big mouthful of water, and then they'll take their tongues and they'll push the water out, and these baleens are like little filters. So that's a little bit weird because our teeth and most other animals' teeth are not made of keratin. So that's a little bit different. But still, the genes for these structures, are still available to be used out there in evolution. So it just takes the same genes and puts them in a different place. Pretty cool. All right, moving on to the epidermis. So as we move up through the layers, we have the stratum spinosum. So cells continue to divide and push to the surface, but the rate of the cell division slows down. They're starting to get away from the blood vessels. So it's kind of like the continuation of what's happening in the stratum basale. Third layer is the stratum granulosum. So this is where cells really start to die, because they're getting farther away, they're losing their nutrients. At the same time, they're becoming more and more filled with keratin, because that's their whole job, is basically to fill up with keratin, flatten out, and they're flattening out because they're receiving pressure from below them, but they're also receiving pressure from above them, because the cells that are closest to the outside, they're not just flaking off individually, they actually flake off in big pieces. So it needs a certain amount of pressure from below. So they kind of get squished in the middle. But they still raise to the surface. They just receive that pressure from above and below at the same time, and they flatten out. The stratum lucidium is only in the thick skin. This is the dense, tightly packed extra layer that is found, again, on the palms of your hands and the soles of your feet. And both types of skin have the stratum cornuum. So it's the outer layer containing hard, dead, keratin-filled cells. So this one, is the thickest part of the skin for the most part. And the cells are dead, they're stuck together, they're water resistant, they're very tightly packed to keep out any bacteria or viruses and water, right? This is the part that will be shed off from the body in large sheets. And large meaning, obviously when you get a sunburn, you receive really large sheets, but large in this sense is that they will be coming off your body in packets of thousands. So they're still going to be really tiny. More on that later. So here's some pictures. Stratum basale down here, stratum spinosum. So the cells are reproducing. They may reproduce a few more times, and they start to get squished as they get pushed up. So they flatten in the granulosum. They really become squished and flattened in the cornuum and stratum lucidium if it's there. So this is cool. It's kind of a real picture. You can see the barrier between the dermis and the epidermis right here. These are called dermal papillae, which we'll talk about in just a moment. So these cells are pushing up, and then you get the spinosum, granulosum, and then the cornuum is right here. And you can see some of these, looks like some sheets of cells are going to be flaking off over here. So it's continually renewing itself, constantly reproducing and making new cells. So that it forms a very, very tight barrier. This is a scanning electron microscope picture, which doesn't really show this detail too much better than this one. You can clearly see the cells there, but you can really see the flaking of the stratum cornuum. It's kind of nasty. But this shows great detail of what happens on a regular daily basis. The skin just flakes off on its own, and you rub your arm against the wall. You're just shedding all of these different pieces of skin. Pretty amazing. And here's a downward picture of the scanning electron microscope. Which these are cool. I mean, the pictures, the colors they add in, go away. The colors they add in are pretty cool. But they're not going to be the actual color. These actually come out black and white. So people add color afterward. But you can see a hair follicle right here. Excuse me, you can see hair coming out the follicles actually deeper down. You can see all these lines and ridges, and so when you're looking at somebody, you know, this is what you're really seeing, but you can't see it because you're so far away. Okay. And this picture's pretty cool. It's similar to the other one I put down there, but this one shows you the skin pigmentation. They're called melanocytes. Basically, they sit in the stratum basale, and what they do is they give pigmentation to the cells as they start to rise to the surface. So you can see they're really darkly pigmented here, but you can see the pigmentation extends throughout this whole area. So I don't know if this person, you know, what their descent is, where they come from in the world. But when I got this picture, it didn't say that. But you can see clearly where the coloration is. You can see the coloration is not in the dermal area. So when you see someone's skin and you see they have a darker pigmented skin, really you're just seeing what's happening on the very, very surface of that. We'll talk a lot more about that next time. All right, so the dermis is basically the leather layer. And I say leather because when people wear leather jackets or leather in their shoes, it usually comes from cows. The epidermis gets scraped away when they process that. But the part that does not scrape away is the dermis. And the dermis is the toughest layer. It's even tougher than the epidermis. And I guess I say tougher because it contains, you know, the collagen elastic fibers that basically anchors the epidermis and the dermis to the subcutaneous tissue below, which really anchors everything below that to the muscles and bone. So it's got some pretty tough proteins in it. The keratin on the outside of the skin is also very tough in the sense that it doesn't allow water, bacteria, viruses in, but it's still relatively thin. So the dermis is much thicker. So this lies beneath the epidermis, and it has two layers itself. It's got the papillary layer, which is the upper portion, reticular layer, which is the lower portion of the dermis. So we're on like 7 layers here. So there's a lot going on. There's actually 8 total. Both layers contain blood vessels, sensory receptors, hair follicles, sweat and oil glands. They're going through both layers. Some of them will, you know, stop and end at different points. Obviously, the blood vessels and the sensory receptors, nervous system are going to continue down into the subcutaneous tissue and go about their different places in the body wherever they're going. But the unique structures are listed here with number 1 and number 2. So papillary layer has dermal papillae, which creates fingerprints, which I'll show you more on that in just a moment. And the reticular layer is also unique because it contains those collagen elastic fibers. These collagen elastic fibers don't stretch up into the papillary layer. These collagen elastic fibers do stretch down into the subcutaneous tissue below, or the subcutaneous layer. The boundaries between these two are indistinct. All right. Most of these sweat and oil glands and hair follicles will end in the reticular layer, but some of them will go down into subcutaneous tissue too. So there isn't like a distinct layer. It's just basically where the gradual change of tissue happens. And what you start to see also is that you start to see many adipose tissues in the subcutaneous layer of tissue. All right. This is also considered connective tissue. So top layers are considered epithelial tissue, but it gradually, as it moves down into the dermis, gradually starts to transition into connective tissue. It anchors the skin to these other tissues. And here's a picture of these dermal papillae. You saw them on the other side. So dermal papillae are all over the body, but on the palms of the hands and the soles of the feet, they're particularly pronounced. And the whorls and loops that you see in these fingerprints, they're there primarily, what they think, is for traction, so to speak. It creates friction from when we are grabbing things with our hands and with our feet, which we don't really do too much with our feet anymore. It creates more surface area to allow us to grip things better. If you look at our ancestors, think of like monkeys and chimps, they use their feet for grabbing things. They also have fingerprints on their feet and on their hands also, their fingers also. So it makes sense. So it's not something that's unique to us. Though it is kind of interesting, this thought question number 5, do identical twins have identical fingerprints? So stop the video and think about this for a second. Alright, hopefully you put something down, do identical twins have identical fingerprints? Bet you a lot of people put yes. It's actually, the answer is no, they don't. Everybody has unique fingerprints. It's made through a completely random process that happens while a child is growing in the mother's womb, when the child is a fetus. Pretty interesting stuff. Alright, so what's the deal with tattoos? Get this little needle here, it doesn't go down too far. This is a needle gun, so what's going on with them? Stamps, like on this dude's wrist right here, on the back of his hand I should say, will wash off. The skin will flake away, even if he doesn't wash his hands for quite a long time. It's still going to go away. And obviously we have tattoos. So, if the skin flakes, how does the tattoo stay? Well, the tattoo gun goes below. The tattoo gun is injecting that ink below the layer of skin where it won't shed away. And the inks that they use, they obviously have to be very resistant to UV light, but they still will fade over time. And there's been some controversy of what they use in these inks. Some people have talked about how there's been heavy metals like mercury and lead, and they wonder if they cause cancer, and I don't know. There's no real definitive answer on them. We're just talking about how they work. So get in that dermis, and it's something that the white blood cells can't destroy, because the white blood cells, they'll want to attack it, but they can't do anything about it. And a lot of them won't even try to do anything with it. They'll just bounce right off them. So that's how they stay. So the needle just goes in far enough to get into the dermis. And here's an interesting picture. We've all seen this with sunlight going into our rooms and our houses. So what is this stuff? Well, just dust. Dust is never just dust inside of our homes. Nope, it's dander, which is another word for dead skin. So it's your own dead skin and other people's dead skin. And if you have a lot of animals in your house, potentially it's their dead skin. So our houses are filled with dead skin floating around. And you're breathing this stuff in constantly. It's not so much a big deal when it's your own dead skin, because your body's going to realize that, potentially. But if it's someone else's dead skin, or a skin from an animal, or a dog, or cat, or something that's living with you, most of the time when people have allergies to cats or dogs, it's not necessarily from the fur, it's mostly from the skin that is coming off of them. And their body is recognizing that as something that is more similar to a bacteria or virus, so you have an immune reaction to them. Pretty interesting. It's kind of gross. This is why even if you're not sick, you cough. And you're coughing up all this crap that you're breathing in, either in your own house or outside, and breathing in stuff that's not dust outside, but it's most likely pollen or dust from some other source, probably from soil. But even when you go inside and you think your house is clean, it's impossible to get away from this. Pretty gross. Alright. Moving on to something grosser. That's a scanning electron picture of a dust mite. And this little dude is feeding on a piece of dead skin. So dust mites love our skin. They live in places where our skin falls off. So basically that's everywhere in your house. They will live on your rugs, they'll live on mattress, sheets, bed, And there's even a bunch of different types of mites that they have found living on people's eyebrows, nostrils. They're obviously pretty tiny if scanning electron microscope needs to be used to pick these guys up, but they're little invertebrate animals, and they're actually related to, most of them are related to spiders, actually. So, we'll leave with that. So, you basically have spiders crawling in your body, in your bed, eating your dead skin, and every time you breathe, you're breathing in your brothers and sisters' dead skin. It's great. All right. Oh, yeah, by the way, they live in your furniture, too. Forgot about that one. Have a good one.